Okay, let's talk a little bit about array lists. Okay, so we've been dealing with arrays, which, it's kind of like we talked about, it's kind of like a bookshelf where you can fill things in the bookshelf, but the bookshelf is going to stay that very fixed size. So you can put stuff in, you can change the values, but you cannot change the size of this array. Um, and this array, elements in here can't even really be empty. Something has to be there, whether it's null or whatever. But we have this fixed size, and it's always completely full. Now, an array list is different. An array list acts kind of like you would think a list starts. Like if you're starting your to-do list for the day, it starts off as empty. Okay, you have nothing there. And then as you think of things that you need to do, you add them to the list. You add and add and add. And then as something gets accomplished off your to-do list, you can remove it from your to-do list. Okay. And just like this to-do list, array lists start off empty. You can add to them and you can remove things from them. Now, just like an array, they have indices, they're ordered. You can change the order. But again, you can add and remove things, which is something that we couldn't do before. So an array list, one of the things that's different from an array is it can only hold objects. Okay, so we can hold strings, we can hold objects that we have created. Now it can hold primitives, but not directly. We'll talk about how we can kind of get around that in just a minute. Okay, but technically it cannot hold primitive values. So here's how we construct an array list. So we say, I am making an array list. And then in these angle brackets, you give the type of object that you're going to hold. So this could be a string, this could be a rectangle, this could be a Pokemon, whatever object type that you have created, it can hold it. All right. And the name of your list, and then new, because we're constructing a new thing, because we are constructing an object. And again, we say, I'm making an array list, and here's the type. Okay, there's no parameters here. There's no arguments because we're making an empty list. So we're just saying, I made the list, and then later on, I'm going to show you how to add to it. Okay, you can construct array lists that are kind of full. I'll show you how to do that later, though. These angle brackets define the type in something called a generic class. The idea behind a generic class is, let's say you have something like an ArrayList class that holds objects of the same type. But that type could be anything. It could be, strings, Pokemon, rectangles, whatever. But you don't want to have to create a different class for each one. You don't want that class to have different methods for each type. That's kind of stupid. So what they do is they basically turn type into a variable. Okay, that's what generics do. They basically write it with this variable t as the type. And then whenever you put in the object type, then it replaces all of these t's with the type. Now, you won't have to write methods like that, but I wanted to explain what this is doing. This is basically going through the entire class and replacing all of these t's with the object type. So if you have an array list of strings, everything in the class now says string instead of t. Okay. Also, real quick, to find how large your array list is, you use size, not length. It's incredibly confusing. So it's size, and we're back to using brackets like we did with strings because this is a method, not a variable. Okay. So let's try this out real quick. So If I want to make an array list of strings, then I say array list, and then I set string as my generic type, call this string list, and then I'm making a new object, array list string. Okay. Um, Now you'll notice I did manage to make an array list of integers. Okay, but what I didn't do, I didn't say this because my array list cannot hold primitive types. So what I do is I use something called a wrapper class. Um, Now, wrapper classes um, are basically, it's what it sounds like. You've got this primitive thing, and then we wrap it in an object so that it can be used as an object, but whenever we want to, we can kind of unwrap it and say, oh, look what I had inside. I had a primitive inside all along. Um, you don't have to stress about this too much. Java is actually really good about um, something called autoboxing and unboxing. Autoboxing basically says if you put in a primitive when it was supposed to be an object, it will automatically autobox it. It will automatically say, okay, it's an object now. And if we use an integer object or a double object or whatever in a situation where we needed a primitive, it will automatically unbox it and say, oh, look, I have this primitive value here. So you don't have to stress out too much about whether you're using a primitive int or whether you're using an object integer, okay? Because it basically converts back and forth pretty seamlessly. But whenever we're making an array list, you have to use the name of the wrapper class, whether that's integer, double, character, or Boolean. Okay, so it can hold these integers, but only in their wrapper class form. Okay, so again, this is not a big stressor. Just again, don't accidentally put lowercase int in there because it's not going to be able to work.